One of the superpowers that we need to gain before we can just go completely off the chain and start picking up chemicals in the lab and knowing exactly what's going to happen, we're going to need to be able to identify different classes of chemical reactions. Once we can identify different classes of chemical reactions, we can better prepare ourselves for what may end up happening and how to predict those products. So again, there are different types of chemical reactions. The first thing that we typically do is categorize them into two major different categories. Those categories are double replacement and redox reactions. Now, it's actually pretty easy to tell the difference between a double replacement reaction and a redox reaction. A double replacement reaction is always between two compounds. Always between two compounds. Now, I want to be very clear here. Things like O2 or Br2 or I2, those do not count as compounds. Those are diatomic elements. So don't let those confuse you. It's literally you need two different element symbols attached to count as a compound. But if you have compound plus compound, that's always 100% of the time a double replacement reaction. Redox reactions are luckily even easier to tell the difference between. They're quite literally any other combination. So if it isn't a compound plus a compound, it's quite literally going to be a redox reaction. So I have a couple example problems for you. I wanted you to try out this new skill. Take a look at these 4 practice problems, and I'd like you to see if you can identify them as either being double replacement or redox. This is a very good step to go through when you're first learning, because from this, there will be other categories. But for right now, just double replacement or redox. All right, time to reveal some answers. So for our first chemical equation, that should be double replacement. It's compound plus compound. Our second one is an element plus a compound. That's automatically redox. Our third chemical reaction is between two elements. That's instantly redox. And our fourth chemical reaction, that's definitely two compounds reacting with each other. That's a double replacement reaction as well. All right, now that you know your two major classes of compounds, it's time to look at some special subtypes. Double replacement reactions have two subtypes. They're called either precipitation or acid-base. Now, precipitation reactions are kind of difficult to see right out of the gate. All of these, by the way, are always still going to be compound plus compound. Precipitation reactions are generically compound plus compound, but they form something called a precipitate, a solid on the product side. When you're just looking at a chemical equation, though, it's a little hard to recognize when you do have or do not have a precipitation reaction. It's actually easier to identify them by process of elimination. Acid-base reactions are very easy to classify, and if it's not acid-base, it's automatically precipitation. Acid-base reactions require an acid and a base. And for this class, we're going to qualify an acid as a compound that always starts with H, and a base as a compound that always ends in OH. So in other words, when you're looking at your compound plus compound reaction, if one compound starts with H and the other compound ends with OH, it's automatically acid-base. If you don't hit those two criteria, your reaction is precipitation. Let's get this a try as well. Here are some practice problems. Now, all of these are double replacement reactions. Notice all of them are compound plus compound. I'd like you to attempt to identify, are they precipitation or are they acid-base? Push pause and then resume for the answers. All right, time to reveal some answers. Here we go. Our first chemical reaction, notice it has starting with an H, the second compound ends with an OH. That guy is going to be acid-base. Our second chemical reaction, neither compound has H in the front Neither compound has OH in the back. This is a classic precipitation reaction. For our third chemical reaction, our first compound starts with H, our second compounds end with OH. This is a classic acid-base reaction. And our fourth one may have been a little bit tricky. Notice that FeCl3 neither has H in the front nor OH in the back. Now, because that single compound can neither be acid nor base, this cannot be classified as an acid-base reaction, even though our second compound has an OH in it. This is a precipitation reaction. Now let's go through this same process, but with redox reactions. Now remember, redox reactions are basically anything that doesn't fall under the umbrella of compound plus compound. Redox reactions are in 4 separate categories, and they are here: synthesis, decomposition, combustion, and single replacement. Now, we will be learning how to predict the products for these reactions in another video, but for right now, we're just working on recognizing them. Synthesis reactions are pretty easy to find. They're always element plus element. Those 2 elements combine to make a compound. So again, you might be able to tell yourself element plus element. Well, that's synthesis. Decomposition reactions are mercifully the exact opposite of a synthesis reaction. So decomposition reactions start with a compound, ripping that compound apart into 2 separate elements. So again, you might be able to say, oop, I just have a compound. And the reactant side, oh, and look, it's splitting up into its elements. That's a decomposition reaction. Combustion reactions are always between the same 3 elements: carbon, hydrogen, and oxygen. Now, the carbon and hydrogen are always in a compound form. We call that special chemical a hydrocarbon. It's the same thing as the hydrocarbons that we put into our cars to get them to go. That's just a special form of hydrocarbon. They always react with the element oxygen and will always produce CO2 plus H2O. Finally, single replacement. It's the only combination that we haven't considered. That's always going to be element plus compound. All 3 of those elements do a little do-si-do, and they kind of rearrange themselves on the product side. But to recognize it, you just need to look at the reactants. Element plus compound. Okay, now let's get into a practice round. Before we do, though, I just want to refresh your memory about what these actually sound like when you're looking at these in English. So again, synthesis is element plus element. Decomposition, just a plain compound. Combustion is always carbon-hydrogen reacting with elemental oxygen. Single replacement, element plus compound. Here's another way to kind of envision this whole scheme all together. So remember that the first thing that you want to identify is the main type of the chemical reaction. That would be either double replacement or redox, compound plus compound, or literally everything else. Once you've identified that, then you can go through and identify the subtype. Precipitation or acid-base both belong to double replacement. It's easier to identify your acid-base reactions than it is your precipitation, so eliminate acid-base first, and then it automatically defaults back to precipitation. Redox reactions come in 4 flavors. Synthesis and decomposition are opposites of each other. Synthesis is element plus element. Decomposition is just plain compound. Combustion, hydrocarbon plus oxygen, and single replacement is element plus compound. All right, some sample problems. Now, this can seem overwhelming, very overwhelming the first couple of times that you actually need to do this, because we need to classify each one of these chemical reactions in 2 ways. First, we need to identify them as being decomposition or redox. So again, the very first thing that you want to do to try and eliminate choices is identify them as being double replacement or redox. So let's go through and let's do that for this sample set of chemical equations. So numbers 1 through 6, take a moment Identify them as acid-base, I'm sorry, not acid-base, double replacement or redox. Push pause, and then when we resume, we'll go over those answers. All right, since we're back, let's go for it. Now, number 1, that's not compound plus compound, so it's redox. Number 2, compound plus compound, that's double replacement. Number 3, that's not compound plus compound, so it's redox. Number 4, that's not compound plus compound, so it's redox. Number 5, compound plus compound, double replacement. And finally, number 6, that's just one single compound, so it's definitely a redox reaction. Now, oftentimes what I'll do now is I'll double back and just start working with my double replacement reactions first. So again, once you have identified your double replacement reactions, now let's see if we can also identify them as either being precipitation or acid-base. So I'll give you a moment to do that now. We only have 2. Identify number 2 and number 5 as being either precipitation or acid-base. Push pause, and then we'll go over the answers. All right, since we're back, let's go over these answers. Number 2, notice that it starts with hydrogen in the first compound. The second compound ends in OH. That's classic acid-base. Number 5 has neither hydrogen in the front nor hydroxide in the back. That's a precipitation reaction. We're getting pretty close. Now that we've identified our double replacement reactions, it's time to double back and now identify our redox reactions. Now remember that those come in 4 flavors: synthesis or decomposition, single replacement, or combustion. Let's take a look at this sample set. Try and see if you can identify them. Push pause, and we'll resume in just a moment. All right, now that we're back, let's go through these sample set. Now, number 1 was a redox reaction, and notice that it's between the element sodium and the element chlorine. That is classically a synthesis reaction. Number 3, that's between the element lithium and the compound NaCl. That's a single replacement reaction. Number 4 is between the hydrocarbon CH4 and the element oxygen. That's a combustion reaction. And lastly, number 6, I only see one compound in the beginning. That is a decomposition reaction. These are going to take a little bit of time to get used to, but I think after you give it a little bit of an effort, you're going to find that you can actually classify these chemical reactions without too much hardship. Good luck.